Good morning. In this two-part lab, we'll be working with both Microsoft Excel and Esri's ArcMap 10 in order to first pre-process data in Excel and then import it into an ArcMap document to map Texas centroids and their differences. One of the most frustrating tasks that we as cartographers may find is that information, while it appears to be readily available, is often not in the formats that we need it to import into an ArcGIS document. This may be available through a variety of sources, including governments, non-governmental organizations, educational institutions, environmental institutions, ESRI, and corporations. At times, the information that we download is already processed and it's ready to import into a GIS spreadsheet, into a GIS. Perhaps it's a shapefile. Perhaps it's already in a database. However, often we download information in a text file or a comma-separated values files. These can be represented by .txt and .c. In the first portion of this lab, we'll be working with both .txt and .csv files in order to pre-process data using Microsoft Excel. For those of you that are taking the Portland Community College Geo265, an introduction to GIS, you'll find that the information is readily available on Desire to Learn. It can be found under the Content section under Module 2. You'll find a zip folder. Once opened, you'll find that there's three files. Lab 2 Excel Texas Centroids, which is the instruction sheet, Places 2K, and USGS Populated Places 1. Now, if you were to click either Places 2K or USGS Populated Places 1, you'd find that the information is in a format that we cannot readily import into a GIS. Viewing it from our notepad, we see that there's a variety of information. AL01, 001, 24, Abeville City, 2987, and a variety of other information. While part of it's neatly sorted into columns, the other part of it isn't. What we'll be doing in this lab is that we will be joining different cities from Texas, from the Places 2K file, in a GIS document, different cities in Texas in the USGS file when we are in our ArcGIS. Now, if we open up the other file, the USGS file, we'll note that the information is in a format that is far different than the one that we downloaded for Places 2K. Here you'll see that each separate bit of information is separated by a feature called a pipe. You notice the pipe. The pipe is just a bar. It can be found on the above your Enter key on the right-hand side of your keyboard while holding the Shift. In order to process this information and make it ready to import into a GIS document, we'll need to open this up in Excel. The next step of our lab is to open up a new Excel document. Going to the Start menu, you can go up to Microsoft Excel. When you have a new document open, the best way to import data is to go to the Data tab, top center. In the Data tab, you'll want to import get external data from a text document. Here you'll need to navigate to your flash drive to find where the information was downloaded and stored. For me, it's in the Geography265 Week 2 folder. I'll begin by importing Places 2K. When importing, I note that Excel gives me two options. Is the data type delimited or is it fixed width? Delimited means it's separated by some sort of value, often a CSV file or comma-separated values, which means that each bit of information is separated by a comma, a tab, a space, a period, a pipe, or some other bit of punctuation. In a fixed width file, each bit of information is separated by a number of spaces. Each column is separated out. For example, in row 1 of the file that we're looking at right now, the first string of information says AL01, 002, 0012, Abeville, space. This to me looks like a fixed width file, where AL would be the state code, 01 would be the Federal Information Processing Code, and 00124 would be the zip code. I'm going to go ahead and choose fixed width. The next part of in order to import a fixed width column, is to choose where you want your line breaks. Typically, this is done by looking at the metadata of the information that you downloaded. This file was imported from the U.S. Census Bureau using a Tiger line file. Here I know that where to place my line breaks. I know that positions 1 and positions 2, in this case the AL, are the state abbreviation. If I were to look at the metadata, it would also tell me that positions 3 and 4, which are the 0 and the 1, are the Federal Information Processing Code for. I'll place another break here just by left clicking. The following 5 numbers represent the zip code for each different place. I'll place another line here. Note that some of the lines are already there for me, and some lines I can't actually place. I cannot place anything in between Abeville and City. We'll have to clean this up later in the Microsoft Excel. If I accidentally click twice and I put a line in the spot that I don't want it to be in, I can just double click it to remove it. I'm going to go ahead and scan over and be sure that all the information looks like it's divided up. Once it has been, I can click next and then finish. You'll note that the spreadsheet that I now have is all into individual cells, where each cell contains a specific bit of information. Column D, for example, is the city name, and then looking over to column K and L, we have the latitude. Considering that we'll be comparing just the state of Texas to the state of Texas, I think I'm going to remove all of the erroneous information. Erroneous in this case are all the states that aren't Texas. To do this, I'm going to use the filter tool in Microsoft Excel. It can be found under the Data tab at the top of your page. If you click Filter, each column gets a little option, the drop-down box. When I click it on column A, I have the option to sort by A to Z, Z to A, by color, or just by which state I want to look at. So I'm going to deselect everything and scroll down to Texas. What you'll note is that now it shows me everything that's just Texas, starting at row number 21,282. Now, right now, if I were to work with this data, save it, it would still save all of the information for all the other states. I need to isolate just the state of Texas. To do this, I'm going to copy and paste Texas onto a different sheet. By going up to the left-hand corner of the spreadsheet, I'm going to right-click so that everything's highlighted in blue, and then copy. At the bottom, I'm going to click on Sheet 2 to create a new sheet. I'm going back up to the left-hand corner, right-click, and paste. This should give me all of the documents just for Texas. So once I right-click and I delete the first row, which is Alabama, I should have all the information for Texas. Of course, it's probably a good idea to be sure that you don't have everything selected before you delete that first row. Let's try this again. Clicking on the first row, right-click, delete. Once this data is cleaned up, we're going to be plotting all this information to an ArcGIS document. Looking at columns K and L, you'll see that the coordinates are in decimal degrees. 31.88387 is not degrees, minutes, seconds format. We're going to go ahead and leave those coordinates alone. But first, we're going to want to clean up this data just a little bit. In order to do that, I'm going to have to remove the city, CDP, and towns in column D. These are census designated. These are census designated designators to whether Abbott is a city, a census designated place, a town. Now to remove these, I'm going to use the Find and Replace tool in Microsoft Excel. I'm going to highlight the column that I want to work with, hit Control F, and go to the Find and Replace tab. Under that tab, I'm going to click Options and see all of the options available. Since we're just removing the city that's lowercase and not any cities that are capitalized, that would be part of the city name, I'm going to click Match Case. In this case, I'm finding city, but I also want to remove the space after Abbott and before city. So I'm going to hit space, city in lowercase letters. I'm going to begin by finding one and replacing one to see if it works. And if it does, I'm going to replace all. This action cannot be undone. Next, I'm going to find CDP, or Census Designated Place. Again, leaving the space and matching the case. And replace all. You should have 318 replacements. The third thing that I will have to remove is town. Again, leaving the space and town in lowercase. I'll find one, replace one, and if that works, I'll replace all of them. Closing the Find and Replace tab, I'll review my information. It looks as though I'm ready to import the Usgs document. Clicking on a new sheet, in this case sheet 3, I'm going to go back to the Data tab and get external data from text, just as before. This time I'm going to choose the Usgs populated places. As with the first document, the text import wizard is going to give me two choices. Is it delimited or fixed width? I know that this information is delimited because I note that there's a pipe or a piece of punctuation separating each bit of information. I'm going to click Next. In this case, I know that the delimiter is a pipe. It can be found above the Enter key on the right-hand side of your keyboard while holding Shift. The text qualifier in this case is quotations. If I put none, you see that each bit of information has quotation marks around it. If I didn't hit the text qualifier as quotations, I would have to go back and find and replace every single quotation mark with nothing. I'm going to click Finish. Now looking at this document, you'll see that I have a lot of populated places in the state of Texas. It shows a variety of information: feature name, feature class, state code, state FIPS, county name, elevation, and latitude and longitude. Unfortunately, in this document, the latitude and longitude are in degrees, minutes, and seconds instead of decimal. The next part of this lab will be to convert the degrees, minutes, and seconds into decimal degrees in order for both spreadsheets to have the same coordinate representation. To do this, I'll have to use a function in Microsoft Excel. I'll first want to separate out the degrees, then the minutes, and then the seconds for my latitude, and reincorporate it into the decimal degrees notation, using degrees plus minutes divided by 60 plus seconds divided by 36. To do this, I'm going to insert a few new columns. We call the first one latitude degrees, the next one latitude minutes, and then the next one latitude seconds. Now I'm going to use the mid function to separate out just the degrees in column K, or latitude degrees. To do so, I'm going to type in equals value mid. Now this function you'll see says mid text, start number, and then number of characters. The text means which column are you working with. The start number is which place are you starting with on the... Perhaps the best way to think of this is that looking at latitude, each place, the 3, the 5, the 1, the 0, the 4, and the n, has one place, where the 3 would be a 1, the 5 would be a 2, the 1 would be a 3, and the n would be a 7. Maybe it's easier to think of it this way. Looking at a Word document that I just created with a coordinate from Texas, I can see that the 3 aligns with the 1, and the 7 aligns with the n. So each place, each integer is represented by a placeholder. In order to separate out just the degrees for this example, I would say equals value mid. It's in column G2. So I want the 35 by itself. I'm going to start with position 1. And then it's going to ask me how many characters I would like to take. In this case, the 3 and the 5, which is 2. That should give me just the 35. Now, if I want to do the same thing, and I wanted to look at just the seconds, my formula would be as follows. Seconds equals the value of mid G2, again working in the G2 column. The 44 for the seconds is represented by placeholder 5 and placeholder 6. So I'll begin with placeholder 5, and I just want the 44, which is 2 places. So I'll again have 2. This should give me 44. Going back to our spreadsheet, I'm going to repeat that process. I2 is the column we're working with. I want to start with placeholder 1, and I want to take 2 integers. Look, now I have 35. Now, to fill this down, I just have to double-click the small black box. I'll do the same equation used for seconds. Alternate slightly to make it work for minutes. Again, it's equal value mid, the column we're working with, which is I2. Place number 3, and they're going to take 2. And that should give me just the 10. Again, I'll double-click the black square and fill down. Finally, for seconds, it's not much different. We're just going to change which places we're working with. Column I2, its value mid, column I2, place, the first 4 is in position 5, and we're going to take 2 places. That should give me the 44. Again, I'll fill down. Now you'll want to repeat this process for longitude as well, creating new columns for longitude degrees, longitude minutes, and longitude seconds. Note, however, that while looking at longitude for Glen Rio, that our longitude is 3 integers instead of just 2, where 103 are the degrees, 02 are the minutes, and 32 are the seconds. I'm going to go ahead and show you briefly. Our equation is going to change. Our equation will stay the same, but the values we type in will be slightly different. In this case, we'll be working with column J2. I'll be working with, starting with placeholder 1, but this time I'm going to take 3 integers. and that should give me just the 103. So we'll label this longitude degrees. I went ahead and skipped ahead. I've completed all the longitude minutes and longitude seconds as well. Now we need to reconstitute the latitude and longitude into decimal degrees. Deci degree. I'll create two new columns. One for latitude and one for longitude. In this column, I'm going to use the equation to convert degrees, minutes, seconds into decimal degrees. This is all based on how many degrees are in a sphere, which are 360. In this case, the equation for latitude will be equals the value of our degrees plus our minutes divided by 60 plus our seconds divided by 3600. Instead of typing in each individual 35 for the degrees, 10 for the minutes, and 44 for the seconds, I'm just going to choose columns. So in this case, it's going to be column place K2 plus L2 divided by 60 divided by 60 plus our seconds, which are in M2 divided by 3600. I hit enter, I should get a number that looks relatively close, where my degrees, minutes, seconds were 35 degrees, 10 minutes, and 44 seconds. My decimal degrees are similar, 35.17889. Go ahead and fill that down. Do the same thing for my longitude, except there will be our latitude's in the northern hemisphere, which we know that's a positive number. However, our longitude is in the western hemisphere, and if we're looking at a grid, that can be annotated as a negative. So I want to make this a negative. To do that, as I know that all of the coordinates I'm working with will be in the western hemisphere, I can just multiply everything in the equation by a -1. If some of the coordinates I was converting were in the eastern hemisphere and some were in the western hemisphere, I would need to be sure that those were annotated in some other way. There's an equation where you can just use the sign, which means taking whether it's a negative or a positive for each value and making that the final longitude. So for example, if one column was -103 and another row in the same column was +99 for our longitude, a signed equation would take the positive or the negative from that. Or for this formula, we just need to multiply everything by a -1. Be sure it's in the western hemisphere when it's in decimal degrees. The equation will be equals value. Again, I'll be working with my longitude degrees first, which is N2, plus our minutes divided by 60, O2 divided by 60, plus our seconds divided by 3600, P2 divided by 3600. Now I'm going to multiply everything times a -1. Be sure it's in parentheses, and I should get a -103.042. I'm going to fill all of those down. The final thing that I'm going to do to make this spreadsheet ready to import into GIS is I'm going to go back to sheet 2, our census places. Note that on sheet 2 there is no title row. So just to make things easy and be sure that it all works out in GIS with no hiccups, I'm going to go back to sheet 3 and remove row number 1, which are all of my titles. We can go ahead, we can rectify that later in GIS. Now that you know how to clean up data from a text or CSV file in Microsoft Excel, go ahead and save your work. Save it as an Excel file to your flash drive. Now we're ready to import this data